This is the third video in the chapter on essential ideas in chemistry. We're moving on to this new topic, measurement and uncertainty, and we're going to talk about 4 subtopics: units and prefixes, dimensional analysis, accuracy versus precision for uncertainty, and rules for significant figures. So in the last video, we talked about the scientific method and scientific theories, and we said that those scientific theories are supported by measurements. Measurements are the evidence that prove those things. Measurements provide the evidence that supports hypotheses and scientific theories in the scientific method. So you too will be collecting evidence, mostly in the laboratory. And when you collect measurements, you need to know that a measurement has several parts. Each of those parts is important. So a measurement contains 3 parts. The most obvious part, the number. So that'd be 5 or 1,000 or 1 times 10 to the third or 17.35. That number can be a decimal or it can be in scientific notation. Most of the time we report things in scientific notation if they're not between 1 and 10, which is most of the time. There's going to be a number. That number is going to have a unit, which is the standard that we compare that number against. And it's going to have an indication of the uncertainty. And that uncertainty tells us how sure we are that the real number is the same as the number that we reported. Okay, so we're going to talk about each of those things. We're going to start with the unit, and then we'll come back to the others. Okay, so we'll start with units and prefixes. So units are the standard we compare them against, and our standard units are called SI units, because SI is an acronym that stands for something in French, which translates to the International System of Units. So all the countries on the planet Earth have agreed that they will use these standard units when reporting numbers, so that there is some sort of agreement. So there are 7 different standard units for 7 different properties, and there's a symbol that we use for each of them. So we'll make a little table here to indicate them. There we are. So the first property is going to be length, how far you can run or how far you can drive your car. The standard unit for that is meter, and it's represented by an M. Another standard property is mass, how heavy something is, and the standard unit for that is the kilogram. And the symbol for kilogram is going to be kg, all lowercase still. We can also measure time, and there is a standard unit for time. The standard unit is the second. Kind of a small unit, maybe smaller than you would have thought, but it is the second. And that symbol is S. There is a standard unit of temperature for how warm or cold something is. And that standard unit is named after Lord Kelvin. And so it has a capital K because it comes from someone's name. We have a standard unit for current, for the number of electrons flowing through something, and that is the ampere, or sometimes you just hear it called the amp, and this is also named after a person, so it has a capital letter. We can measure the amount or the quantity of things, how many things we have. The standard unit for the number of things we have is the mole, and its symbol is mole without the E, technically. And the final property is going to be the light intensity. which you'll probably use a bit more in physics than you will in chemistry. That standard unit is the candela, and its symbol is CD. Okay, so those are our standard units. And when we're measuring things, we can use these units, but sometimes the units are not everything that we hoped they would be. For example, if I wanted to measure the length of something, and let's say I wanted to measure the length of an atom, it would be really, really difficult to measure the length of an atom with a meter because of how much smaller an atom is than a meter. Or for example, if I wanted to measure the length of the circumference of the planet Earth, the meter would be way, way too small. So one way we can adjust these standard units without coming up with a new unit is to use something called prefixes. As we make smaller and bigger versions of these, so we can still technically be measuring in the standard unit. So each of these prefixes is going to have a word, it's going to have a symbol, and we'll list the size, how much smaller or bigger it is than the normal unit. So for example, we'll start from the smallest end. The smallest unit we're going to do is pico. If we put pico in front of meter, 1 picometer is 10 to the 12th times smaller than 1 normal meter. So we're going to do 10 to the negative 9th, 10 to the negative 6th, to the negative 3rd. We'll throw in another couple here, negative 2nd and negative 1st, because we use those numbers a lot. 10 to the 0, and then we'll do some prefixes for things bigger than the standard units. 3, 6, 9, and 12. Trying to plan ahead on my paper here. There we go. So 10 to the 9th times smaller than a standard unit is called nano, with the symbol N. 10 to the 6th times smaller is called micro, and 10 to the 3rd times smaller is called milli. And those both start with an M, so they can't both have a symbol of M. So we're going to use M for milli, and we're going to use the Greek letter mu for micro instead, so that they can both technically be M. 10 to the negative 2nd is centi, and we use C for that. 10 times smaller than the standard unit, we use deci, and a D stands for that. And then 10 to the 0 is 1. That's just the normal standard unit. Okay, and then over here we've got larger units. So 10 to the 3rd meters would be a kilometer or a kilometer. 10 to the 6th times bigger than a standard unit would be mega. And we're using a capital M now. 10 to the 9th times bigger is giga. We use capital G. And 10 to the 12th times bigger is tera with a capital T. Table is not as pretty anymore. That's okay. There we are. So let's do an example. So if I wanted to use this prefix kilo in front of grams, a kilogram already has that unit in it. So let's pick meters instead. So 1 kilometer is this many of the standard unit. So it's 10 to the 3rd of the standard unit. And we can try another one. How about micro? And we'll use that with seconds. So 1 microsecond is this many, 10 to the negative 6 seconds. So in this case, we're adding a prefix to make the unit smaller. And in this case, we're adding a prefix to make the unit larger. Okay, so this is how we use the standard units and the prefixes to make those standard units smaller and larger. In the next video, we'll talk about dimensional analysis and how to convert from one unit to another.